If you grew up in Britain in the 1950s, you remember the smell. Ether and castor oil, sweet and heady, identical to Castrol R at a racing circuit, coating your hands and your clothes in a dark film that wouldn't wash out. You remember the sting of a propeller blade catching your fingertip on a cold morning, and the harsh cackle of a diesel engine settling to a purposeful buzz. The engine that started first flick every time was a Mills .75, machined to aerospace tolerances of 1/10,000th of an inch in a converted builder's workshop in Woking. Then a conglomerate bought the factory and switched off the production line to chase aviation contracts. The tooling was shipped to Calcutta. The site was redeveloped. Today, 143 Goldsworth Road carries no trace of the factory, and no plaque marks the ground. This is the story of Arnold Hardinger. Born in Germany as Arnold Neumeister, fled the Nazis, survived bomb disposal, taught himself precision engineering, and the 92,000 engines he built that defined a generation's childhood. Not through one disaster. Through a single balance sheet calculation that decided model engines were less interesting than defence contracts. Chapter 1. The German Boy and the Gramophone Needle. The story of Mills Brothers engines doesn't begin with the Mills Brothers. It begins with a man born Arnold Neumeister in London in 1906, the son of a German father named Walter. When the First World War broke out, Walter Neumeister was interned on the Isle of Man. The family relocated to Germany in 1914, and Arnold grew up there, not as an engineer, but as a businessman. He worked as an executive for Ford Motor Company in Berlin, then moved to HMV, his master's voice, where he was involved in gramophone development and worked alongside recording artists. He was comfortable, established, building a career in the music industry in a country sliding towards catastrophe. In 1937, Arnold Neumeister ran afoul of the Nazi authorities. The specifics are lost, but the consequence was absolute. He fled to England and adopted his mother's informally assumed surname, Hardinger. Arnold Louis Hardinger. A new name for a new life in a country that was, within 2 years, at war with the one he'd just escaped. What Harding did during the war was extraordinary. He worked in bomb disposal, one of the most lethal occupations available to a civilian with German heritage trying to prove his loyalty to his adopted country. And somewhere between diffusing unexploded ordnance and staying alive, he taught himself precision machining. His son Michael, born in 1944 and later a lecturer in psychotherapy and philosophy at Regent's College London, captured what happened next with an economy that deserves quoting in full. At the war's end, my father was totally at home in the machine room. The idea just occurred to him, and then he was informed by a highly qualified RAE engineer that it could never work, so he made one. The idea was a compression ignition miniature diesel engine, a tiny functioning motor small enough to power a model aircraft. The Royal Aircraft Establishment engineer was so certain it couldn't work that he insisted on testing a prototype aboard a Lancaster bomber at altitude, expecting the thin air to kill the compression. It ran perfectly, and the fuel control needle in that first engine, the component that meters the diesel fuel with the precision required for a compression ignition cycle to function at miniature scale, was a 78 revolutions per minute gramophone record needle, available wholesale for pennies from his HMV days. In one exquisite detail, everything Arnold Hardinger had been before he became an engineer converged into the thing that made him one. The Mills brothers themselves, Bert, Frank, and a third whose first name history hasn't preserved, were Sheffield men who'd been manufacturing model railway equipment since before the First World War. Their Milbro brand produced O-gauge tinplate locomotives, track and rolling stock from premises at 129 St Mary's Road, Sheffield. Their handmade wooden coaches in real teak veneer were noted for striking realism, and by 1938 they'd opened an elegant showroom at Southampton Row in Holborn, a neoclassical building that survived the Blitz and still stands today as a Grade II listed structure. But the Mills brothers didn't design engines. They provided the name, the commercial framework, and the initial distribution. The genius was Harding's. On the 20th of May, 1946, a patent was filed jointly by Mills Brothers Model Engineers and Arnold Lewis Hardinge for improvements in or relating to miniature compression ignition engines. The first commercial engine, the Mills 1.3 cubic centimetres, was advertised in July 1946 at £5, 5 shillings and sixpence. Roughly a week's take-home wages for an average worker. The age of the British model diesel had begun, and its capital would be a converted builder's workshop in Woking. Chapter 2. The workshop on Goldsworth Road. In late 1946, a dedicated manufacturing facility was established at 143 Goldsworth Road, Woking, Surrey, premises that had formerly housed a builder, plumber and decorator. Arnold Harding managed the operation. It was intimate rather than grand. Reg Elton, who started work there in the spring of 1947, recalled that early crankcases were hogged from the solid on Myford ML7 lathes, the standard British workshop lathe of the era, not the specialised transfer machinery a larger firm would have installed. Cylinders were manufactured externally by the Precision Reed Company of Crawley in Sussex. Crankshafts initially came from Sheffield. Assembly and testing took place at Woking. Michael Harding's childhood memories of the factory are vivid and faintly terrifying. I have many memories of him working in the Mills factory at weekends, where I would wander around marvelling at the array of machinery, of course totally illegal under the Factory Act. Even more so, my father's habit of temporarily removing the safety guards around cutting heads so that he could see exactly what was happening. A child wandering unsupervised around unguarded cutting machinery. A different era's notion of acceptable risk. By late 1949, Hardinger had purchased the model engine business outright from the original Mills Brothers, who continued manufacturing model railways separately as Mills Brothers, Sheffield, Limited. The divorce was clean. Hardinge kept the engine name and focused exclusively on what he'd created, handling wholesale distribution directly after ending an earlier arrangement with E. Keel and Company, the firm behind Keelcraft model aircraft kits. The product line that emerged from Goldsworth Road was small but precisely targeted. The Mills 1.3 cubic centimetres came first, approximately 36,500, produced across 4 variants over its lifetime. The Mills 2.4 cubic centimetres appeared in September 1948. A rear rotary valve design that was commercially unsuccessful and is now the rarest collector piece, with only 3,000 to 3,500 ever made. The factory backed onto residential areas, and the persistent noise complaints from engine testing may have influenced Hardinger's decision to discontinue it. But it was the third engine, introduced in August 1948, refined into its defining Series 2 form by November 1949. That made the reputation. The Mills Point 75 cubic centimetres. Over 51,000 produced. More than half of all Mills production. The engine that Ron Chernich of Model Engine News described flatly as the greatest and most popular all-round sport engine to come out of England of all time. Beyond model engines, the Woking factory manufactured high-precision prototype components for Vickers Armstrong, the Royal Aircraft Establishment at Farnborough, and the Ministry of Defence, typically one-off experimental pieces in difficult metals requiring extreme tolerances. Hardinge, as his son recalled, delighted in facing such challenges, particularly if very small components were involved. This sideline in defence work sustained the factory's income and kept its precision capabilities sharp. It would also, in time, prove to be the reason for its destruction. Chapter 3. First Flick. What made the Mills .75? The most celebrated model engine in British history wasn't one quality. It was a constellation of design decisions, each one a small act of engineering perfectionism that collectively produced something greater than the sum of its tolerances. The crankcase was gravity-cast magnesium alloy with chromate anti-corrosion blackening, light, strong, and resistant to the corrosive fuel mixture that ate lesser engines alive. The piston was hardened and ground tool steel, a significant departure from the cast iron used by competitors, giving exceptional durability. The cylinder liner was nitralloy chromium molybdenum steel, hardened and ground too. Bore tolerances of plus or minus 1/10,000th of an inch. Aerospace-grade precision for a model engine retailing at £2.10. The gap between the quality of the object and its price was almost absurd. Trevor Wooderson, the brilliant designer who created the .75, the 1.3 Mark II and the 2.4, had engineered something that belonged in a different price bracket entirely. The engine's secret weapon was its patented dual-stream transfer port system. Fuel-air mixture entered the combustion chamber in two separate streams that impinged on each other and struck a flat deflector machined into the piston crown, atomizing heavy fuel droplets and ensuring thorough scavenging. The result was the characteristic that made the .75 legendary: reliable first-flick starting, even for complete novices. In an era when getting a model diesel running could reduce grown men to frustrated profanity, a Mills .75 would start instantly, run reliably across a wide RPM range, and last virtually forever. It weighed just 1 3/4 ounces bare. Its long-stroke design, bore of 0.330 inches, stroke of 0.520 inches, produced excellent torque across a range from 6x3 propellers at 12,000 revolutions per minute down to 8.5x3 at 6,700. Builders had enormous flexibility, and the engine kept going, year after year, flight after flight. That last quality was, ironically, a commercial problem. Engines that never wore out suppressed repeat purchases. Hardinge had, in effect, engineered himself into a market ceiling. The sensory world of what these engines created is a documentary filmmaker's gift. Model diesel fuel was a mixture of ether, 30 to 35%, kerosene or paraffin, castor oil, and a trace of amyl nitrate as an ignition improver. The sweet, intoxicating smell of ether layered over the heady warmth of castor oil, identical to Castrol R racing oil, the perfume of every vintage motor race in Britain, is a Proustian trigger for millions of British men. One enthusiast captured it simply: "The smell of diesel fuel is addictive. It is a perfume." The castor oil lubricant passed through the engine unburned and coated everything nearby in an aromatic, sticky, dark film. Your hands, your clothes, the fuselage of your model carried the residue like a badge of honour. Starting the engine meant flicking the propeller, risking the sting of a blade catching your fingertip on a cold morning, while adjusting the compression screw until the engine fired with its distinctive harsh cackle, settling to a purposeful buzz when properly tuned. That sound, that sting, that smell. For a generation, they were inseparable from boyhood itself. The competitive landscape surrounding the .75 was crowded. Electronic Developments in Kingston-on-Thames was the volume leader, producing over 2,000 units of a single model per month, against Mills's total of roughly 750 across all types. Their EDB at £2.05 undercut the .75 considerably. Frog, part of the Lines Brothers empire in Merton, offered the Frog 100 at £2.08. The Albon Merlin from Davies Charlton, introduced in October 1954, was a direct competitor at £2.07 and £6. Mills engines were never the cheapest or the most powerful. They were the best made and the easiest to use, occupying a premium position in a market where the cluster of manufacturers in Surrey and southwest London, Mills in Woking, ED in Kingston, Albon in Sunbury-on-Thames, Frog in Merton, formed a miniature industrial ecosystem. As Adrian Duncan noted, the model engine industry was a significant employer in southwest London in 1948. Think of the Crake in all those engine makers' pubs. The proximity to the Royal Aircraft establishment at Farnborough was not coincidental. Chapter 4. 500,000 air-minded boys. To understand what Mills engines meant requires understanding their cultural moment. British aeromodelling in the late 1940s and 1950s was not a niche pursuit. It was a mass national hobby. By 1945, the Society of Model Aeronautical Engineers had over 500 affiliated clubs and an estimated 500,000 model flyers. Every boy who had watched Spitfires defend British skies wanted to build one. When Airfix released its Spitfire kit in 1953 at 2 shillings from Woolworths, the gateway opened to virtually any child with pocket money. The organised scene had establishment credentials that seem almost surreal now. The SMAE's 1948 awards dinner was held at the Dorchester Hotel. Guests included Lord Brabazon and the Minister of Civil Aviation. The Queen and Princess Margaret visited model flying events that same year. In 1957, Prince Philip became patron of the SMAE and remained so for 64 years until his death. F.J. Cam, who had named the Society of Model Aeronautical Engineers in a Camden Town tea room in 1922, was the brother of Sidney Cam, designer of the Hawker Hurricane. The chain from full-scale aviation to model aviation was direct and personal. The most remarkable venue was the Model Sportsdrome at Eaton Bray in Bedfordshire, a 72-acre purpose-built facility opened by D.A. Russell, managing editor of Aeromodeler magazine. British Pathé newsreel footage of Eaton Bray survives. During the war itself, model flying competitions continued at Epsom Downs, with photographs showing large piles of chalk in the background placed there to deter German glider-borne landings. The British carried on. Mills engines were exported throughout the Commonwealth, Australia, New Zealand, India, South Africa, with Polk's Model Craft Hobbies serving as the American distributor, though diesels never gained traction in the States, where they were dismissed as oily and smelly. The domestic and Commonwealth markets were Mills's heartland, and in those markets the .75 was something close to a standard, a default. The engine you bought if you wanted it to work. That was the summit. Approximately 92,000 precision engines, built by hand in a converted builder's workshop in Woking, sold across half the world, powering the hobby that 500,000 British boys called their own. Arnold Hardinge, the German-born bomb disposal veteran who'd taught himself engineering in wartime, had built something of genuine beauty and extraordinary utility. And then a company called Ailing Industries arrived. Chapter 5. The Reasonable Acquisition. In 1960, Mills Brothers, Model Engineers Limited, was acquired by the Ailing Industries Group. On paper, it looked like good news. Ailing professed interest in continuing and expanding engine production, and Arnold Harding remained as plant manager. The Woking factory would carry on. The engines would keep coming. The arrangement seemed to anyone watching from the outside like a sensible corporate marriage, a small precision operation gaining the backing of a larger industrial group. But Ailing's interest wasn't in model engines. It was in what the model engines had inadvertently created, a precision machining facility staffed by workers whose tolerances matched anything the aviation industry could demand. Hardinge's sideline work for Vickers Armstrong, the Royal Aircraft Establishment at Farnborough, and the Ministry of Defence had demonstrated that the Woking workshop could produce one-off experimental components in difficult metals to specifications that larger firms struggled to achieve. Hardinge delighted in that work. He didn't see it as a threat to his engine business. He saw it as a compliment, proof that his factory operated at a level beyond what model engineering required. Ailing saw it differently. They saw a facility whose most valuable capability was being partly occupied by the manufacture of small engines retailing for £2.10 apiece. The aviation subcontract market paid better. The margins were wider. The clients were the British government and its defence contractors. The arithmetic wasn't complicated. For 4 years the two operations coexisted. Engines continued to be produced. Defence contracts continued to be fulfilled. But the balance was shifting. Every hour of machine time spent on a Mills .75 crankcase was an hour not spent on a Vickers Armstrong prototype component that paid more per unit. Every square foot of floor space occupied by engine assembly was a square foot that could be generating aviation revenue. The logic was patient, incremental, and, from a balance sheet perspective, unanswerable. The model engine market itself was changing beneath them. Globally, the hobby was shifting from diesel engines to glow-plug engines, where Japanese manufacturers like OS Max and Enya were building a dominance that British firms couldn't match. The transition from control line flying to radio control demanded larger, throttle-equipped engines unsuited to small British diesels. Rising manufacturing costs squeezed margins further. Television was competing for boys' attention. The 500,000 air-minded boys of the late 1940s were growing up, and the generation behind them had other distractions. None of this made the Mills .75 a worse engine. It was still the finest sport diesel ever produced in Britain. But the market for finest sport diesels was contracting, and the parent company holding the factory had somewhere more profitable to point the machines. Chapter 6. The line goes quiet. In mid-1964, Ailing Industries terminated all model engine production at Woking to free the factory's resources entirely for aviation contracts. There was no succession plan, no transition period, no attempt to find a buyer who might continue manufacturing. The production line simply stopped. Arnold Harding, then approximately 58 years old, retired. His son Michael was only about 20 and had no mechanical aptitude. He would go on to build a career in psychotherapy and philosophy. Trevor Wooderson, the designer whose engineering brilliance had created the .75 and its siblings, had already left years earlier for a career with Vickers Armstrong and later BAE Systems, where he became a celebrated flight deck design engineer. The knowledge that had built those engines walked out of Goldsworth Road and dispersed. Peter Chin, the most respected engine reviewer in the British hobby press, described the closure as nothing short of a national disaster by those who had come to regard the .75 as almost indispensable to the survival of the hobby. Adrian Duncan recalled his own reaction with the directness of someone still processing the loss decades later. I well recall my own feelings of shock and loss arising from the news of their departure from the scene. The closure wasn't an isolated death. The entire British model engine industry was collapsing around it, one firm at a time, like a terrace of houses falling in sequence. Lines. Brothers had ended production of the entire frog-flying model range in early 1962. The last frog engine advertisement appeared in April 1966. The moulds, the physical tooling that embodied decades of British design, were eventually sold to the Soviet Union. ED, the volume leader who had produced over 2,000 engines a month from their West Molesey premises, suffered a devastating fire on the 29th of April 1962. Their chief engineer, Gordon Cornell, had already resigned over management inaction on research and development. The company survived, but never recovered its dominance. Davies Charlton, maker of the Albon engines that had competed directly with the .75, saw quality decline steadily after designer Alan Albon departed in 1959. The firm limped on until the mid-1980s, though the Albon Dart achieved a remarkable 34-year production run from 1950 to 1984, a testament to the quality of Albon's original design outlasting the company's ability to maintain it. The Surrey and South West London ecosystem, that cluster of precision workshops within pub-crawling distance of each other, all feeding off the Royal Aircraft Establishment's proximity and a nation's appetite for model aviation, disintegrated within 2 decades. The manufacturers who'd built the engines, the suppliers who'd machined the components, the retailers who'd sold the kits and the fuel and the propellers, the magazines that had carried the advertisements and the reviews. An entire industrial culture, modest in scale, but exquisite in craft, gone. Only PAW, Progress Aero Works of Macclesfield, survived. They continue to manufacture diesel engines today, the sole continuous British model diesel producer, a solitary survivor making engines in a world that has largely moved on. Chapter 7. Calcutta, Collectors and the Silence on Goldsworth Road. Even before production ceased, Ayling had been looking for a buyer for the engine operation. Not out of sentiment, but to extract residual value from assets they no longer intended to use. In April 1963, an Indian businessman named Suresh Kumar, already involved in model kit manufacture through his company Aurora in Calcutta, expressed interest. Negotiations continued through 1963 and into 1964. A revenue receipt dated the 24th of April, 1965, confirms the completed purchase. The mill's name, goodwill, worldwide manufacturing rights, original master drawings, production tooling and die casting equipment, the last of which had been held by Stone Woolwork, Charlton, Limited of Woolwich. On the 30th of April, 1965, Mills Brothers formally confirmed complete cessation of all Mills engine-related activities at Woking. Remaining spare parts were taken over by a retail outlet called Woking Models. The factory was done with engines forever. Kumar registered the Aurora Model Manufacturing Company Private Limited on the 10th of February 1966 and commenced production of Mills reproductions at Foreshore Road, Calcutta. Aurora eventually exported approximately 33,000 Mills, 0.75 and 1.3 reproductions, nearly 40% of the original total production, though quality was described by collectors as hit and miss. The precision that Hardinger and Woodison had insisted upon, those tolerances of 1/10,000th of an inch, couldn't simply be shipped to another continent and replicated. The tooling was the same. The hands were different. The institutional knowledge that turns a set of drawings into an object of precision had stayed behind in Woking, dispersed among workers who'd moved on to other trades. Kumar also acquired the Allen Mercury engine range and, in 1969, the Taplin Twin. He died in 2010 at 88. His son Rishi took over the business, finally closing the engine department in September 2013. The last echo of Mills' production fell silent in Calcutta, half a century after it had fallen silent in Woking. But the engines themselves, because Arnold Harding had built them to last forever, refused to disappear. The Mills .75 holds a distinction no other model engine can claim. It is the most replicated miniature engine in history. Irvine in England produced superb quality reproductions until the late 1990s. Gordon Burford's Taipan operation in Australia turned out approximately 1,500 in 1974, highly prized by collectors today. Derek Giles in England made small quantities across a range from 0.2 cubic centimetres to 5.0 cubic centimetres. Les Saxby produced extraordinary 0.13 cubic centimetres versions. A mini Mills so small it defies belief that it functions. Versions have been manufactured in Russia, China, New Zealand and the Czech Republic. Aurora in India, holding the legal rights, successfully pursued legal action against at least one unlicensed replicator. Imitation, in this case, was the sincerest testimony to what Hardinger and Woodison had designed. Original Mills engines trade today at £40 to £400 or more, depending on model, condition and provenance. The rarest, the 2.4 cubic centimetres, of which only 3,000 to 3,500 were ever made, and any surviving prototypes command the highest prices. Collectors are served by the Model Engine Collectors Association, with approximately 1,000 active members across more than 20 countries, and organisations like SAM35, the Society of Antique Modellers, in the UK. The factory site at 143 Goldsworth Road has been entirely redeveloped. The area now features mixed commercial and residential properties with major redevelopment schemes underway. No trace of the original Mills factory remains. No heritage plaque marks the site. A man who fled Nazi Germany, survived bomb disposal, taught himself engineering, and built approximately 92,000 precision engines in a converted builder's workshop. And the ground where he did it carries no memory of him at all. Chapter 8. What the Silence Keeps. The closest significant museum is Brooklands in nearby Weybridge, which covers the broader Surrey engineering heritage. But Brooklands tells the story of aviation and motor racing at national scale, Vickers, Hawker, the banking circuit. It doesn't tell the story of the small workshops. The places where a handful of people, working to tolerances that the aviation industry itself respected, produced objects of genuine beauty for a market of boys and their fathers on weekend flying fields. Arnold Hardinge wasn't killed by the closure. He retired and lived on. The persistent story in hobby circles that a founder died in 1964 and the company collapsed doesn't withstand scrutiny. Exhaustive research across multiple authoritative sources reveals no documented death of any Mills principal in that year. The myth is more dramatic than the truth, but the truth is more devastating. No one died. A conglomerate simply decided that model engines were less interesting than aviation contracts and switched off the line. The cruelty wasn't personal, it was arithmetic. The contrast pairs in this story write themselves. Aerospace grade tolerances of plus or minus 1/10,000th of an inch in an engine costing £2 10 shillings. A bomb disposal veteran's wartime survival leading to the creation of objects of delicate beauty. A German-born Englishman adopting his mother's assumed name to build quintessentially British engines. A prototype tested aboard a Lancaster bomber to prove a skeptic wrong. And the most striking of all, a product so well made that its very durability undermined its commercial viability. Manufactured by a company so small that its parent could simply switch it off. 92,000 engines, built by hand, in a workshop that used to belong to a builder and decorator. They survive today in their tens of thousands, in sheds and glass-fronted cabinets and collections that span 20 countries, and on flying fields where men in their 70s and 80s still flick propellers on cold mornings and catch the scent of ether and castor oil, and remember being 12 years old with oil on their fingers and a buzz in their ears. The smell hasn't changed. The sting of a propeller blade on a fingertip hasn't changed. The sound, that harsh cackle settling to a purposeful buzz, hasn't changed. The engines were built to last forever, and they have. Everything around them, the factory, the industry, the 500,000 air-minded boys, the world that made such things possible and valued them. That's what didn't last. The silence on Goldsworth Road is the only monument they have.